Okay.
So in the database world, you're having different kind of words, or I can say like a jargons, or I can say like a keywords, or different kind of things. But how you are going to classify those things, how you are going to call them. The first thing is an entity. For example, employee is an entity. A person is an entity. A place is an entity. Object, anything, whatever the thing you are calling it as an entity. Okay, so in the data modeling world or in a big like architectural world, so entity means what? It can be anything. If a person is saying entity, means that can be related to a person, that can be related to a bank account, that can be related to a place, okay, that can be related to a specific event like account transaction or deposit. Everything is a kind of an event. Okay, so normally in our homes, like if any function is happening, okay, if we are celebrating something, then we can call it as an event. Even if you go to a bank, you open an account, okay, that's called an event. Okay, whatever the transactions are happening, so those things are related to event in account opening. So for that specific account opening activity, you might call it as an event. Okay, then what is the attribute? Characteristics of an entity. What is that? If I'm opening an account, that's an event. But when you're opening an account, what are the things related to that transaction or related to that activity? The first thing, type of transaction. Account opening is a type of transaction. Okay, so instead of type of transaction, I can say kind of transaction. So what are the other attributes? Amount, minimum deposit amount, another transaction. Account opening date, another attribute I can say. Okay, so the person who opened the account, another attribute, or the amount withdrawn or amount deposited during the account opening, that is an attribute. So whatever the things related to the specific transaction, that specific event is called an attribute. Okay, so these are the attribute we are going to store in a table. Okay, so what exactly you are calling the attribute? You are calling it as a column. If you are taking an employee table, employee number, employee name, salary, there are three attributes. What are the attributes name? Employee number, employee name, salary. These three are attributes. Then what is the transaction? What is the transaction or event? Event means employee name, employee number, salary. Okay, like employee name John, employee number 101, salary 10,000. So what I can say in other words, so John is an employee with 101 employee ID and is earning $1,000 salary. This is called an entity or account. Let's select account opening entity. What is account opening entity? How it looks like? The person called John opened an savings account on so and so branch on so and so date with so and so amount. How many attributes are there here? This is all called a event. But within this event, how many attributes are there? Customer name John, customer account type savings account, the date of opening on January 1st, 2017. Okay, the amount he deposited, so $10,000. So these are the attributes. Do you get my point in the business terms?
Yeah.
Okay, so you can relate anything now. You can relate it to the marketing, you can relate it to the retail store, you can relate it to any Best Buy or anything. Whatever the transaction is happening, that is called entity. Whatever the attributes or characteristics of specific entity is called an attribute. So when you convert these two things into a table or into the relational database, then a table is a specific place where you are going to store these events and these attributes. So when you're calling a complete list of attributes, okay, in a single statement, that is called a record. Okay, a group of attributes is called a record. When you're talking about the individual attribute, is called a column. Okay, the best example is employee table. Employee table, your employee table is having employee name, salary, employee name. These three are attributes. Okay.
Okay.
No. So these are the few kind of words, and there are a couple of other things, couple of other concepts we're supposed to learn. So, but this is the core basics. Okay, what exactly is going to store into a table? Because table is kind of a lowest granularity into a database. Okay, ultimately a database administrator or a developer or a tester, all of them are going to work on tables in a different ways. But ultimately, where they are working on a tables. Okay. So what are the basic data concepts, like foundation data concepts means, what are the basics on the database side? If you look at the database, basically forget about all these words and whatever the keywords mentioned here. First of all, try to understand what is a database, why a database is required. So don't look into the slide, try to understand like this. Before understanding any concept, first you need to understand why that concept came into the market. First of all, what is the necessity of that concept into the market? So earlier, if you remember, like in olden days, people used to write, if you go to the bank, I don't know whether you've seen this or not, we used to have a passbooks in India. What is the meaning of a passbook? Whatever the transaction you are going to perform or you performed in a bank, they are going to write in a book. It's kind of a normal kind of a checkbook. It won't be like a checkbook, like a small kind of a notebook. They are going to write everything in that notebook. So amount withdrawn and the date and everything. So the days pass on, like the people started computerizing the things. So when I'm saying computerizing is what? They are storing the data electronically. What do you mean by electronically? They are storing the data in some place in the form of 1 and zeros, the digital format. So when they're storing the data in the digital format, to the outside world, how they're going to access is a big thing. So they are going to access the data in the form of a user-readable format. A user-readable format so that the people, the employees or the customers can understand the data. So that's how they built a place called database. Because if you are simply storing the data, you can store in the form of a 1 and zeros. That's okay. So only the machine can understand. But if you want to understand a normal person or a normal human being to understand the data, it should be in a specific format. That format, I'm calling it as a database where my data is going to store. Okay. So earlier people, there used to be machinery languages, like they used to read, the machines used to read in 1 and 0 format. So the same thing, the 1 and zeros, they molded in the form of a database so that the regular users can feel the data, can see the data, the way they looked into the data in their boss books, the same way they can see the data into their machines. Okay, that can be a tablet, that can be a workstation, that can be a mainframes, anything. But it's a human readable format. That's the place I'm calling it as a database. So why you are not calling it as a website? Why you are not calling it as a cloud? Why you are not calling it as a kind of a Almara or whatever it is? Why you are not calling? Because to store the data in a website is a different process. To store the data into a cloud is a different process. To store the data into a notebook is a different process. But to store the data only for the retrieval purpose is a different process. To store the data, to organize is a different process. That process I am calling database management system. Okay. So where I'm storing data in the databases I'm storing. Why I'm only in the databases? Because databases are built. Okay, the term database came from I don't know like who invented the term database, but like the term created because of the data. So where I'm storing the data is called a database. If I'm storing the data in a place in a moon, then it's a moon database. A data I'm storing for the bank related information, it's like a bank related database. Like that, I named different kind of databases. Now you might ask, like, who invented this database? Okay, so the people who invent the database, even I am not sure like who invented the database, but like why they invented the database, what is the necessity? If you ask me, the necessity is to make sure the human can read the data in effective way. That is only the basic necessity to build the database. Okay, hope you understand why database came now. To make it a computerization, they build the database. Now everything looks good. Okay, everything, a human can read the data. But how effectively they are reading the data is question. For example, if you are having a book, textbook, there are like 1 million pages. Are you able to get a specific information, whatever you want from 1 million pages? Yes, you can get it, but how effectively you are going to get? Or how much time you are going to take to get the data? Everything matters. Then the people thought, okay, just storing is not matter. or just storing the data will not resolve any purpose. We need to have a specific mechanism to link a different kind of information. Okay, there should be some kind of a mechanism. That mechanism called relational database management system. Okay, so relational means what? If I'm having 100 tables, I'm going to create some kind of a link. If I'm having an employee data, if I'm having a salary information, there should be some kind of a link between these two tables so that I can read. I can join these two tables and I can collect the data. Okay, so why you need to join is a different story. Okay, again, it's kind of an ocean. I don't want to go into deep, but like what I'm trying to say is like why exactly these all are required. Okay, when I'm saying a relational database means what? You are going to perform a referential integrity means what? A primary key and foreign key relationship. In other words, I am relating two different kind of a tables by using two different kind of a attributes. Those attributes I'm calling as a primary key, foreign key. Okay, so that kind of a system is called RDBMS. Now let's go back. Let's go back to the basic terminologies what we will use in the DBMS and RDBMS. So most of the things like are pretty much same other than this referential integrity compared to DBMS and RDBMS. So forget about the DBMS now. Just think about the RDBMS because that is where you are going to work. Okay, so DBMS is a kind of a older concept. Next, when the RDBMS came, then it ruled the world. Okay, this completely changed entire system. So now, so what is the database now? Database is collection of different kind of tables. Same thing I mentioned. Wherever you are putting the data, okay, that's called a database. But how you are going to put the data is then the matter of tables comes into the picture. What is the tables? So let's go back to the first thing like entity and attributes. Okay, when I'm calling the entity, for example, bank is an entity. Okay, within the bank, I can say accounts is an entity, loans is another entity. But I cannot put accounts information as well as loans information in one table, right? I need a separate table so that it looks good. So whatever the data is related to accounts, I'm creating a table called accounts. Whatever the table is related to loans, I'm going to create a loans table. Like that, I'm going to create multiple tables. Okay, based on the event or based on the transaction or based on the business functionality. Okay, like that, I'm going to create different kind of entities. I'm naming them as a table. Okay, that is the core information about the table. Now let's see what is the bookish kind of a data or bookish kind of a definition. A collection of the related records. When I'm saying banking related information means all the records, whatever you're storing in the banking table is banking related or banking oriented data is specifically stored in the bank table. Okay, next, record. What is a record? It's a collection of a fields. Earlier, whatever we discussed, attributes. Okay, when you're combining all these attributes, I'm calling it as a record. Okay, so record means, for example, in the employee table, employee number, employee name, salary. So that data will be 101 John, salary is 20,000. So 101 John 20,000 is a record. Like that, you can have million records. You can have n number of the records into the table. Is that clear?
Yeah.
Okay, now the next is field. Employee number is a field. Employee name is a field. Salary is a field. So a field can be anything. Means a field can be a kind of a character type. A field can be kind of a numeric. A field can be kind of a floating value. So you might confuse like what is a numeric, character, floating. So character means whatever the things you are trying to put in that field, okay, by using characters like A to Z or some symbols like underscore, dot, comma, whatever it is. Everything is in a character. This kind of a field I'm going to call as a character fields. This can be different. This can be have different kind of names in each and every database. Okay, in Oracle, you might have it as a character. In DB2, you might call it as a varchar. In Informatica, you can call it as a something like. So there are different kind of terminals, but ultimately the meaning, the background of the specific field name or field type is a character. You're going to store the characters. Next, integers. means integers means what? Like the numbers 1, 2, 3, 4, 5. Like these are the called numbers. You may call it a decimal or a number or integer. So the field type can be these three: number, integer, decimal. So based on the thing you are going to mention. Other one is double float. So these two different kind of things are meant for the values which are having the decimals, like 23.23 or 23.45 or 123 point something. Like that, wherever you are having a decimals, you are going to put in the decimals and floating values. So this is another kind of a field or another kind of a data type, I can say. There is another kind of a data type like called date. All the dates, okay, all the dates which are talking about a calendar value, it's called a date data type. Okay, so there are different varieties of fields. Okay, there can be numbers, there can be characters, there can be dates, there can be floating values, anything. So everything I'm going to call as a field. Okay, now the character, this is the least and least in your data world. Character means what? Anything is a character. Okay, A is a character, B is a character, Z is a character, dot is a character, space is a character, everything is a character. Even sometimes if you put like 1 and define it as a character, then it will convert hexadecimal values. Okay, it will convert as in a character. Okay, so anything can be converted as in a character. Is that clear? That is the least granularity on the data side. Okay, so this is what I'm explaining right till now. So if I'm saying last name Mike, okay, so M is a character, I is a character, K is a character, E is a character. So the whole thing you are going to call as a field, but individually this field is formed by using a characters. So this is what I'm talking about for name, sex, and weight. So Eric Bremer, yes, 263 is a record. Did you get my point?
Yeah.
So like this, Eric, I may have John, I may have like Krishna, I may have like Shruti, like that. I can have n number of the records. Record means the total thing I am calling as record. Record doesn't mean that only Eric is a record. No, this whole thing I am calling it as a record. Does that make sense?
Yes.
Okay, when I'm calling only first name, then it's called a field or a column. Okay, when I'm pointing only to the Eric, then it's going to call a specific field. But when I'm pointing, if you are having like a couple of other records like Eric, John, Krishna, like that, then the whole thing I'm calling as a column. Did you get my point? Vertically, yeah. Whatever you select is a column. Horizontally is a row. Maybe like you might feeling like I'm teaching very basics, but still I don't know, like I thought like it will be a good starting point.
Yes.
Okay. Maybe out of 100 point, at least if you feel like 1 point is a valuable, then it's much helpful. Yes. Okay. So next, so this is what I'm talking about. When you're talking about the first name, Eric, Jeff, Jackie is a column. The complete list is a column. So what is the column name? First name. Last name is another column. Sex is another column. Age is another column. What is the row then? Eric, Premier, M30 is a row. Okay, very, very important because this terminology you should know.
Yes.
Okay. So basically when you're putting bunch of the tables, okay, when you're putting all of them together, you're going to call as a database. When you're trying to relate each and every table, then it's going to call as a relational database. All this managing this data or like organizing these tables in a particular fashion is called a relation database management system in simple way.
Yeah.
Okay, this is what I'm talking about. Relating the tables. So when he's pointing the 508 customer ID in orders table, he's pointing in the customer. So here you need to understand two different kind of things. That is like primary key and foreign key methods. Okay, so are you aware of these two, primary key and foreign key?
Yeah, I know a little bit.
Okay, so basically primary key means what? Like, so for example, if you look at this, the customers CID, customer ID is a primary key, because whenever I'm talking about a primary key means if I'm defining something as a primary key, that is a unique. If I'm saying in the employee table, employee number is a primary key, what does it mean? If I'm having an employee number, okay, let's take a best example, like you're in your school, you're having a roll number, like a
Yeah.
30. Okay, so if you're having a rule number 30, there is no chance any other student from your class will have the same number as 30, same rule number as 30, right?
Yeah.
There is no chance at all. That is called a primary key. So in your school, for your class, the primary key is your student number. Okay. For example, the same student is enrolled in different kind of a classes. Like the same student is enrolled in dance class. The same student is enrolled in mathematics class. The same student is enrolled in art class. Okay. So if you look at the dance class, so in the dance class with the same number, so whatever your hall ticket number or like sorry, whatever your student number, rule number 30. Okay. In the extracurricular activities table, for example, you are participating in like 3 extracurricular activities. One is dance, another one is like arithmetic, like mathematics, and the third one is maybe you can take chess. These are all extracurricular activities. But the student number, the school roll number is same 30, 30, 30, right? But you are going to assign a different number in extracurricular activities table. That is called extracurricular activities ID. Maybe you are going to have extracurricular activities ID as a different number. Like for chess, you are going to have extracurricular activities ID as 1. For mathematics, arithmetic, you are going to have as 2. And for dance, you are going to have a 3. Here, extracurricular activity ID is a primary key, but your class number, roll number is going to be a foreign key. Make sense?
Yeah.
Okay. So, but like the same ID, if I want to join your extracurricular activities as well as your school table or the classroom table, then I am going to use your ID, the school ID or your roll number 30 to join these two tables. That is called a referential integrity. As this is here, see the example over here. In the customer table, CID is a primary key, but the same customer ID in orders table is going to be a foreign key.
Yeah.
Does that make sense? In the products table, product ID is a customer key, but in the same value or the same field, if it goes to orders table, is going to be a foreign key. So ultimately, my orders tables is having two different kind of a foreign keys and one primary key. At the same time, customer tables are having one primary key and product table is having one other primary key. So all of these tables are interrelated. So it's a relational databases. Does that make sense?
Yeah.
Okay. So there is another thing called traditional file processing. So always data doesn't mean that it's going to store in the tables. Even the data can be stored in the files. But how the data is going to store in the files? The same thing. It's going to store in the form of a specific format. In the tables, I'm calling it as a rows and columns. But when it comes to the tables, files, it can be a different way of storing. But organizing is same, but the process, the way is completely different. So when we are talking about the files, there are two different kind of a major varieties of files. One is fixed width, other one is comma delimited, or a delimited file instead of comma, I can say. Delimited means what? You can use any kind of a character. That can be comma, that can be semicolon, that can be anything. You are separating two different fields by using specific character. Okay? Does that make sense?
Yeah.
This is a typical database. Okay, if you look at this. So customer transactions, so I don't want to confuse you, but it's kind of a database, or like I can say, which is having a different kind of I'm sorry, this is not a database. This is basically a traditional file processing. So basically they're having a different kind of a files, okay, and they're trying to process all of these files in a specific order. Okay, so I don't want to jump on this thing. Right now we are discussing on the databases. So I don't want to confuse you by bringing the files into this. Okay.
Okay.
I'll come back to this 10th and 11th slide later once we're done with the database management approach. Okay, so now let's see like database management approach. So that is where we are going to start the process of DBMS, database management systems. So what is the database management approach? First of all, why we need this approach? Basically, it consolidates data records into one database that can be accessed by many different application programs. So software interface between the users and databases, data definitions is stored once separated from application programs. So now the same thing whatever we discussed initially. Why we are using the databases, why we are using the tables? To make sure the normal user can read the data. So how he is going to read the data? Everyone cannot have an access to databases, right? To look into the data. Some people, if you are going to the bank, how the bank people will read the data? You don't write any SQL queries whenever you come to the branch, right? What he is going to do? He's going to open an application. So for example, if you are opening your Yahoo or like your Google, Google is not a best example, but like we are opening a Gmail, okay? When you open a Gmail, so what exactly you're going to see? Or let's take this this website, global.gotomeeting. This is what a GoToMeeting website. But how you're going to see in a specific order in perfect user readable format. He created this application or he created this website, okay, by using the data because in the background he's having so KTech data. In the background he's having some kind of a logic, some kind of a data, some kind of a content with scheduled meeting. If you want to create a meeting for a certain time, this is not coming like this is not stored in the application. It's stored in somewhere in the database.
Yeah.
So all this information is coming from specific place. That place I'm calling as a database. But why I'm creating this application? Because so that the user can read efficiently. That's the reason I'm creating this. Even if you open your email, everything, whatever you do in the IT industry or in the application industry or in the data world or like whatever the world which are related to these computers, all the data is coming from some place. That some place I'm calling as a database. How you are present to your user, it doesn't matter. But in the background, definitely there is some kind of a place where you are storing the data. Okay, so different kind of people may access the data in a different ways. So you need to have a separate kind of a data managing system, database managing system. That's the reason they introduced DBMS concepts. Okay. So now software interface between users and databases. So this is one of the software interface. What is the software interface? Maybe a Java oriented program or some kind of a program which create by using that they created this website. That can be a PHP or whatever it is. So that is kind of a software interface. Data definition is stored once separately from application programs. Even when I'm typing something like if I type like google.com, what is going to happen? Whatever the data you are putting here, like KTech, okay, what are the information you are putting over here? So all these images and everything based on your input only, right?
Yeah.
So this input has to go into somewhere, or else how you are getting this?
Yes.
I don't want to talk the mechanism, how it's happening, but somewhere it's supposed to go. Okay. Maybe the best example is if you do like a gmail.com. Okay. So when you type something, so what I did, basically I didn't log in anything. Let me give a better picture. Okay. If I want to log in into this, now the password, whatever I'm giving, okay. When I click on sign in, what exactly happening in the background? My username and my password are going somewhere and trying to compare, right?
Yeah.
If I give the wrong password, it won't accept. If I give the right password, then only to accept. So what mechanism is happening? Somewhere this comparison is happening. So already happening means what? There are already some place, my details already there. For krushkatech@gmail.com, this is what the password. Storing somewhere.
Yes.
Okay, so that's why to maintain that storage information, I need a DBMS concepts. Hope you understand my point.
Yeah.
Okay. So the same thing, like he's trying to explain. So the same thing, whatever I explained now, is putting in a pictorial format. Whatever the password I gave here is going to the database management system, checking account program or savings account program, whatever it is. So if you take the simple Gmail example, when I type that sign in, those details will come into database management system, and those details will go to the customer database, and it will check is that ID is equals to this password. If it is matches, then it will go to the specific whatever it is like. Okay. So basically, whatever by the background, the story is whatever the input you are giving, it will go to the specific database, it will take it back, and it's going to check some other databases, and it will take that, compare it, then give the results. Okay. So don't go in depth of that, but try to understand in the background for any kind of an operation, there is some kind of thing which is handling that some kind of thing I'm calling as a database management systems. Okay.
Okay.
So what is the DBMS then? So maybe in the book level, a software that controls creation, maintenance, and use of the databases. In other words, this is a kind of a system that handles or controls your databases. Okay, in simple terms. So what are the different kind of components in the database software components? So before going for the components, you need to understand in the real world, what are the database softwares? Oracle is one of the database software. MySQL is one of the database software. SQL Server, Oracle, DB2, all are different kind of databases. Okay, so why you need those softwares? Because even though you are talking about a database, you need some kind of a mechanism, some kind of a layout, some kind of an interface where you can access the database, right?
Yes.
So when I'm saying Oracle means what? Like you are trying to log into the database and you are trying to look into the data. For all these things, you need some kind of a platform. That platform, this Oracle created. That platform, this DB2 guys created. That platform, this MySQL guys created. They are created different kind of a platforms with different kind of features. Okay.
Okay.
Now, so these are the basic things like in the database DBMS software components. So transactional processing, database tuning. So basically, whatever they mentioned here, you need not to worry about those things. You are not going to perform those things. Try to understand the terminologies. Okay. So basically, transaction processing means controls to prevent the interface from simultaneous users. So what do you mean by simultaneous user? When you're having a database, at the same time, n number of people can communicate with the database. N number of people can communicate, or a number of people try to get the data, try to put the data. So many transactions, so many access related things. So maintaining all these things called transaction processing. And the next thing is tuning. The tuning is very, very, very important in the data. It's because the world data means like it's not like one record or two records. There are billion, trillion records. If you don't have proper tuning, it's going to be a real, it's going to almost like impossible to get the data back. Okay, to retrieve the data is like almost impossible if you don't tune properly. Okay, so that is the importance of the tuning. You can perform different kind of operations like even if you're talking about the Informatica, there are different kind of tunings. Even if you're talking about the Oracle, there are different kind of tunings. Okay, so there are different kind of methods and operations as part of the tuning. Is that clear, Shruti? Any
Yeah.
questions as of now?
Yeah. Yeah. I'm good, Krishna.
Okay, maybe today you might feel little bored, but like yeah, from tomorrow onwards, like we'll start the real data warehousing concepts.
Okay.
So now, how you are going to access the database is a big question. So you need some specific kind of a language, right? So if you want to talk to some other person, you need to understand their language. Then only you can communicate with that person. The same thing, if you want to communicate with the database, you need to understand the language of the data. That language I am calling as a SQL. Okay, just give me a sec. Sorry. So you need a specific kind of a language. That language I am calling as a SQL. Here you need to understand SQL is common language for all the databases. Okay, I'm talking about the relational database. When I'm saying all the database, that means relational databases. So that those SQL, the language, structured query language is going to be common, but the syntaxes might be little different. Oracle might have a different kind of syntaxes, DB2 might have different kind of, everything is going to be different. But ultimately the background, the language, the base language is same. Just like an accent will be different, okay, in across all the states of US. But the basic intention and the basic language is everything is English. The accent might be different. The same thing, SQL also. The way they use the language is different. But the bottom line is the everything, the functions and almost all. Now I cannot say functions are same, but I can say the way they use the SQL structured query language is going to be same. But somewhere the syntaxes and there could be new functions, there could be a less functions in MySQL, or there could be more functions in MySQL. But overall, the language and the usage is almost same. Shruti, can you hear me?
Yeah.
Okay. So whenever I'm talking about database, it doesn't mean that database means like once you store the data, that's it. You're going to just managing the data. No. Database means every day you can have n number of records into the database. For example, you take the Walmart business. Every minute, every second, there are going to be a lot of transactions into that database. So you're supposed to manage that kind of a data as well. And updating the database to correct data and ensure accuracy of the data. So if you're having data, that doesn't mean that whatever the data is there in the database is correct. You need to have some kind of a mechanism to maintain the accuracy. Or else it's going, if you are simply dumping the data, there is no meaning, right? If you are not having a accurate data. So there should be some kind of a mechanism which is going to maintain accurate data which is retrievable. So application development means like it's going to be the same thing. Accessing the database, you need some kind of an interface. So that interface I'm calling as an application. So basically, what are the applications they are building? Application development, that can be a Java application, that can be any application, .NET application, any kind of application. So what are the application you are building? So that should be linked to this database. So this database and this application is having a inevitable relationship. So did you get my point?
Yeah.
So when I'm talking about the application development, almost like every user interface technology is there in the market, everything I can talk about. Okay, so maybe best example I can say like a Java. So these are the basic core concepts, Shruti. So tomorrow we are going to discuss about the data warehousing concepts. Okay, and you can see like all of my concepts in the pushkartech.com. When you open the Pushkartech, so when you go to the Informatica, these are all of the concepts what we are going to discuss. Okay, so I didn't mention the database concepts because like this class is like different one, but like the rest of all the concepts is going to be same.
Okay.
Okay, when we install the Informatica, then I'll spend some time on the Linux also. But like as of now, how about the installation? Did you download all the files, Shruti?
Uh, I didn't start any installation in my system.
Oh, okay. So did you get a chance to download the files?
No, I just download